Okay. So in the last class, till the last class, we have seen what to test as part of ETL testing. What are the different areas we need to focus on, and also we discussed a few things about the documentation, right? So in the process, ETL testing process, we required a few documents like a data model. We need to know what are the tables we have in the source and targets, and then we should have a mapping document. So these two documents should be ready at the time of requirement analysis phase. So once we are ready with the data model and mapping document, and then our tester job will start. So first we need to understand the what are the tables and relationships and what kind of data it contains, and also the mapping document. So in the mapping document, usually uh, they'll specify they'll specify all kinds of mappings between the source and the targets. Okay, so what we need to do is we need to understand what kind of transformations we need to apply on the while moving the data from the source to targets. So that kind of information we can see on the uh, mapping document. So that is the main core and important document for the ETL tester. Okay, and then we will see how to write the ETL test cases based upon the mapping document. And here people will expect more skills on writing SQL queries. So that is major area you need to focus on. Okay, so we have to write SQL queries, very complex queries sometimes. So you need to practice a lot. So that is the main 60 to 70% of the skills will be from SQL commands, writing SQL queries, right? So now let us write while writing the ETL test cases. Parallelly, we need to also prepare some kind of test data. So here the test data means the queries will become a test data. Okay, now so let us see, I'll show you a few documentation now. So today we will see how, where we need to start, how we need to analyze the mapping document, how we need to understand, then how we can write the test cases and so on. And parallel, this is all manual tasks. Okay, so once we completed ETL test cases, I will also show you how the ETL developer will apply the transformations, how the ETL developer will load the data from the source to target by using queries. And that is a manual process. And the tester point of view, we need to validate the data, right, in the target tables. So as a tester point of view, what kind of queries we have to prepare and how we need to validate the data in the data warehouse. So that's we have to see at the tester point of view. So today we will focus on them. This is a purely manual part. Okay, so next weekend I'll show you how we can do this through query search tool, and we see some real time project, how it happens in the real time, and how the mapping documents will be in the real time. Okay, now today I have taken a basic scenarios like a HR schema. uh, so we have a source tables and we have a target tables, and then we have a mapping table. And let us understand this first, and then we go for the writing ETL test cases. Okay, right? So now let me share presentation. So data model and the mapping document. So as I discussed, ETL mapping document contains basically columns mapping between the source and target, and data type and the length for all the columns of source and target, and then transformation logic for each column. Then ETL jobs, I'll tell you what is ETL job and all. And DB schema and source and target, you should keep handy to verify any detailed mapping sheet. So before going to mapping sheet and writing test cases, we should keep ready with the source and target tables and everything. So these are the basic data models we require. Now we will see uh, sources, targets, and ETL mapping sheet on HR schema. I'll provide you all the scripts. Okay, don't worry. Whatever I am using in the class, everything I'll provide you. Okay. Now, so let me move on to the documentation part. Just a moment. So 1 second. Right. Now, first of all, let us move on to the mapping sheet. So here itself, this itself contains the source tables, target tables, mapping, and data validation queries. Everything I have kept here. So we'll go through one by one each and every query. Parallelly, we will execute these queries also. Okay. So first thing, as a very beginning, we should have the source. We should have the targets. and then we should have a mapping sheet. So these are the three input documents. We don't prepare this document as a tester. This is not our responsibility to prepare these documents. Okay, these are from the business analyst. These documents are from business analyst, and sometimes the ETL mapping document is prepared by the business analyst, but there is another document called as a design document. So that will be prepared by the developer. So whatever the ETL mappings the developer have been created, so that document will be provided to the tester. Okay, so that's the ETL mapping sheet. So that ETL mapping should be approved with the business analyst. Okay, then based on the ETL mapping sheet, the developer implement the queries for uh, loading the data from the source to target, while apply and with respect to, and also he will apply the transformation before loading the data from source to target. So that is the job done by the developer. Once the data is loaded into the target tables, then our tester job will ready. Okay, tester has to validate the data in the data warehouse. Now let us see here. I have some sources. This is all about the HR schema. Okay, so this is basically Oracle. So today I'll completely focus on Oracle source as well as target, and the next week we will see other database like MySQL database. Okay, so basically the query search will support multiple data types, multiple databases, but query search require the license. Okay, we don't get any license, so we need to purchase that. So they provide the trial version. So in the trial version we can use only MySQL database. So for other databases, if you want to use, we need to purchase the license. Okay, the trial version will be available for 15 days. So during those 15 days we can practice. Okay, so in the next week I'll cover that part, how we can do in the other databases and everything. And today we'll focus on completely Oracle and HR schema. So on that particular schema we will see what are the source tables, what are the target tables, how mappings will be updated, and then how we can write the test data, and how we can write the test cases and so on. Now when you come here, these are the source tables. Source tables have in the HR schema, this is the data model. So here regions, countries, locations, departments, jobs, job history, and employees. So these are the many tables we have. Okay. So this is basically a model, data model. So for this model, I have a detailed tables here. This is a structure of the employees table, departments, jobs, and job history, regions, and countries, and locations. So there are 7 tables we have. So every table we have a different columns, and every column of the data types and size, and the keys have been specified. Keys means the primary key, P means primary key, U means unique key, F means foreign key. Okay. So table names and column names and the data type and size of their columns and the number of keys have been specified here. Now we have a data model. So while seeing this data model, we can understand what are all relationship between these particular tables. So these are all the source tables first of all. Okay. So after seeing this source table, what we need to do is we need to connect to the source database. We need to connect to the source database and need to check whether these all the tables are present or not. That's the first thing. And these tables should be present and the data should be available. That's a prerequisite. As soon as we get this document, source tables and schema, first we need to connect to the source database and then check all the tables and the data is available on the source tables or not. That we need to verify first. Now go to the target tables. So basically the target tables are available in the target database, right? So here, these are the target tables we have currently. This is a sample and for demo purpose I have created. Okay, this is not exactly the real-time data and real-time tables. Okay, I'll cover that part in the with the query search. So there we will take the real-time customers and sales data. Okay, this is for your understanding. So before going to that levels, first we need to understand the basic things, right? So how the ETL testing will happen, where we need to start, what are the different tasks we need to perform. So these things we have to be very clear at the beginning stage. So here these are the target tables. So if you observe these target tables, EMP underscore total underscore sal TRG, EMP DEPT underscore TRG, and if you observe the names of these tables, it is end with the underscore TRG. TRG means the target. Okay, there are 7 tables I have here. These are all the target tables. Now, when the data will be ready in the target tables, once the ETL jobs are completed by the ETL developer, then the data will be ready in the targets, right? So at the beginning level, the data will not be available in the target tables. Once the data is loaded into the target tables, then the data will be ready. But what we need to verify here is, first of all, we need to check the tables are available or not. First of all, at that time of designing, we are not yet enter into the execution part. We are still in the designing part. Okay. So at this point of time, what we need to verify is, we need to connect to the source database and check all the tables are available, and also data should be ready. Data should also be available. And the target database we need to connect and check the table structures are available or not. Data will be come in the later part, but now at least the table should be ready in the target table, target databases. And structure we should check. All the columns on the data types are correct or not. These things we need to verify at the high level. Okay, these are the target tables. Now we have a source tables and also we have a target tables. Now we need a mapping document, our mapping sheet, where what are all the data should be loaded into the target. So we don't we don't do ETL for all kinds of data from the source to target. Okay, based on the requirement and the mapping sheet, we do it. So when you come here, mapping sheet, see this is a mapping sheet. So this mapping sheet contains n number of mappings, but here I have created few mappings for only employee table. Okay, for employee table, I have 7 target tables. If you see here, these are the 7 target tables. But for these 7 target tables, the data will coming from only one or two tables, not more than that. Okay, because this is a sample document I have created, so that I use only one or two tables. But in the real time, you have n number of tables, countless, and there are n number of target tables. First of all, you need to know from which table to which table the data is populating. That we need to understand. So if you observe here, I have used employee table and I have used department table. Most of the times I will use only these two source tables, but I have 7 target tables here. So these 7 target tables, the data will be coming from the employee as well as department table. And if you see the target tables, this table contains different types of columns. Okay, there is no rule like whatever columns we have in the same source table, the target table also should have the same column. There is no rule like that. So there may be, the column names can be anything, but the data is important for us. Okay, so as per the requirement was business document, so what are the kind of data we need to pull from the source, and what kind of data we need to store in the target database columns? That is more important thing. So here I am considering only few tables. There are one or two tables from the source, and the target tables I have 7 tables. I have 7 target tables. Now we need to pull the data from the source to target. Now here we require the mapping sheet. So this is a mapping sheet. So I have created 7 different mappings, because here is I want to demonstrate all kinds of transformations. So each and every mapping will cover a certain kind of transformation. Okay, so that is more important thing here. So here I have created a multiple mappings between source and the target. So the template will be seems like this. This is the same as a template. If you go for the real-time documents also, the template will be same like this. So here we have a source table, and what are the columns in the source, and what are the data types, and in the this side we have a target table, and here we have a different columns and the different data types. And now we have to apply some movement. That is basically transformation. So if I see here, what is the transformation here? What kind of transformation I have to do here? If I see the employee ID column, I don't want to move anything. Just I directly move the data to the employee ID. So here employee ID from employees table to employee ID from employee total sal underscore target table. So this is direct move. Direct move means we don't need to change anything. Direct move means it will directly pull the data from the source and put the data in the target. Similarly, first 4, 5, 6 columns I'm not touching. Exactly whatever data we have in the source, the same data I move to the target table, and especially these particular columns. Okay, sometimes the column names will be same, sometimes the column names will be different, but we don't need to consider the column names exactly with the data. Proper data from the specific column to specific column from the target table is moving or not, that we need to consider. And here, especially for the hire date and commission underscore PCT and salary, right? So these two things, and one more is hire underscore date. So I have some rules on these particular columns. So before moving the data to the target, I want to apply these particular rules on those columns. Okay, that is basically called as a transformation. So transformation means there is a rule which we need to apply on the columns. So if you observe this hire date, in employees table, we have a hire date. But if you come to the target table, the column name is changed. Here, this is experience. Experience column is there. But what kind of transformation I need to apply? What is the rule here? That we need to understand. So round off sys days hyphen high date divided by 365 comma 0. This is basically SQL function in Oracle. What this will do is the experience will be updated in the years. But usually in the employee table we have a hire date. Based on the hire date, we will calculate number of experience in the month, number of experience in the years, right? So, but I don't want to move hire date exactly as it is in the target table. So before moving the hire date into the experience column, I need to apply this particular rule. Then what happens? This will return the experience of the employee. It will return the experience of the employee. How it will return? 6 days means today's. Today's date minus hire date and divided by 365. If I do like this will give you the year, a number of experience in the years, in years. So that value will be stored into the experience column. So this is a kind of transformation. This is basically expression transformation because we applied some calculation. Similarly, if you come to the salary and commission underscore PCT, I have two columns. But if you come to the target table, we have only one column, that is total underscore salary. Right. So what is the rule here? Transformation rule is whenever I want to pull this data to the target table, I don't want to salary, I don't want to pull commission underscore PCT. I don't want these two columns. But before pulling into the target table, I want to add these columns and then the final result will be sent to the this particular column. Total underscore salary is a target column. So how we need to do this? Salary plus commission. Okay, I'll add these two. And one more point here. Check null values in each column. And if null value is encountered, override it to 0. Sometimes the commission value will be nulls. So in that case, what we need to do? Whatever the salary is already existed, we need to add 0. Null means null is not a 0 exactly, but here the rule is applied like wherever the nulls are occurred, instead of nulls, just replace with the 0 and add salary and commission. Then pull the uh, load the data into the total underscore salary column. Okay, so in the source table we have two columns, but in the target table we have only one column. It should contain a sum of salary and commission. That is another transformation rule which we need to apply on these two columns. Right? This is a one mapping. So for one table, employees table to the target table is employee underscore emp underscore total sal underscore target. So this is the target table. And before moving the data from the employees to employees total target table, we need to apply these conditions. And this will take care of ETL developer. He has to write his own queries, and while he is executing these queries, what will happen is the data automatically load to the target database. Once the data is loaded into the target database, that we need to verify whether data is accurate or not based upon this mapping sheet. So as a tester, what we need to do, how we need to verify the data in the target database? We should also write our own queries for validating the data. That's the next step. So first of all, we need to understand all the mappings, and then we will think about how we can write our own queries for testing the target tables. Okay. Now basically these are all expression transformations. I have applied expression transformation on three different columns. Okay, this is the mapping one. Next, Let us go to mapping 2. So in the mapping 2, I have taken the same table again, but this time the target table will be sum underscore sal underscore depwise underscore target TRG. This is the target table. Now here I have applied aggregator transformation, especially on some salary column. In the target table, I have only two columns, sum underscore salary, department underscore ID. But in the source table, we have n number of columns. But in the target table, I have only two columns. But what about the remaining columns? Don't move. Don't move means I don't want to move this data to the target table because we don't have those columns in the target table. We have only two columns. But what kind of data we should get these columns? Only the salary and department ID. And salary also it is not direct move, right? So we need to apply some sum of salaries and department wise. I need some department ID. In each department, there are many number of employee salaries. There are many number of employees are working under the same department, right? I want to get the sum of those all employees. So that's my requirement here. If I see this target table, I would know what are all departments are available and each department what is the sum of salary. That information I want to analyze. So here I have only two columns, but department ID, this is a direct move. It will come directly. But when you come to the sum of salary, how we will get this from salary to sum of salary? We need to apply a method, sum of salary on department wise. Here we use group by class. Okay. So while writing the queries, we will know again how we need to put this into the query format. So salary column also we should not direct move into the salary under sum underscore salary. So before moving this column to the target column, we need to apply this particular transformation. Okay, so this is basically aggregator transformation because this is the aggregation function. It will work on group of outputs, right? So this is another mapping. So here we have only source table is 1 and target table is 1. But in the source table we have multiple columns, but in the target table we have only two columns. Next, mapping 3. So in the mapping 3, again we have a same source table, but the target table is different. So in the target table, emp underscore dep underscore trg. In this target table, we have a column names. All columns, mostly every column is present. Whichever column is there in the employees table, mostly all the columns are present in this table and their data types. And what is the transformation we need to apply? Let us see here. So all these columns are direct move. Direct move means we no need to apply any transformation, just employee ID to employee ID, first name to first name, last name to last name, the direct move. We no need to apply any transformation. When you come to the department ID, we need to apply some transformation. What is the kind of transformation? It is filter transformation. Filter. So what condition we need to apply? Only records which have department ID 10 will be loaded into target. Rest of other records will be dropped. Okay, that is the transformation. So for example, in employees table we have 1000 records. We don't need to pull all 1000 records into target table. Wherever whichever record is having department ID 10, only those records we will load into the target table. So that is how this transformation says. Okay, this is basically filter transformation because we are applying some condition on the rows, number of rows. Wherever the department ID equal to 10, we will move only those records to the target table. This is another kind of mapping, third mapping. And come to the fourth mapping. So here I have two source tables, employees and departments. I have two sources, HR underscore employees and departments. Okay, these are two sources. Now if I see here under two sources, if I combine all these two tables, we have these many number of columns, right? So till here, till these records, for example, employee ID to department ID, these records are from employee and these four records are from department departments table, right? So now we have a two tables, HR employees and departments. So from these two source tables, we need to move the data to the one table. The target table is only one. Now, what are the transformations we need to apply here? So here, employee ID to manager ID is the direct move. Direct move means we can directly move these records into the target table. This is the direct move. We don't need to apply any condition or transformation. But when you come to here, department IDs, department name, only these columns, right? But in the target table, we have only department ID, department name. We don't have manager ID, we don't have location ID. So we no need to move these records. Manager ID, location ID is not required because we don't have those columns in the target table. So we need to move only employee ID and the department name. But how we need to move? What is the rule we need to apply here? Load all the employees if employees.department ID matches with departments.department ID with department. So this is a rule we need to apply. So what rule is saying is we need to move department ID from the employees table which is matches with the department ID from department table. Okay, for employee table we have department ID. This is the one, and this is the one, again one more employee ID which is from department table. If both are equal, only those records we need to load into the target database. So in which column? Department ID and department name columns. Okay. So this is a joiner transformation because we are applying the join on two tables. So here we need to write a join statement to achieving this particular requirement. Okay. So these are the sources first of all. So once we load, this is the basic transformation. So rest of the columns we should not move anything. Only we need to move department IDs and department name. That's it. And these are the direct move. Sorry, all other columns are direct move. And here manager ID, location ID we don't move. And only department ID, department name we need to apply the transformation. Okay, this is a mapping 4. So here we have applied joiner transformation. Whenever we use joins, that's basically called as a joiner transformation. Okay, sometimes we have one table, two tables, more than two tables. If you have more number of source table and if there is one target table, we must apply the joiner transformation. Okay, now the next one is a mapping 5. So in the mapping 5, this is again another kind of aggregated transformation. We already seen one aggregated transformation above. This is the one more transformation. In the transformation 5, observe here again the same table, employees table. We have these many columns in the employees table, and in the target table, EMP underscore count underscore sal underscore department wise underscore TRG. This is my target table. But in this target table, I have only 3, 4, 5 different columns. I have only 5 columns. First column is number of employees and maximum salary, minimum salary, average salary, and department ID. I have only these columns in the target table. Now, what is the rule we need to apply here? The first till employee ID to job. I don't want to move any records. Don't move these records into the target because we don't have associate column values in the target table. But what are all columns we need to move? And here commission-PCT, manager-ID also we no need to move. Only we need to move salary and department ID. And if you observe here, the salary, if I want to move, there is no salary column in the target table. Similarly, department ID is there, but department ID we have to move directly. It is not direct move. We need to apply certain condition. But how we need to get number of employees, maximum salary, minimum salary, average salary. So if you want to get these values based upon, we need to use a salary column. Right, so how we need to get these values from the salary column? We need to apply these aggregator functions like maximum salary, minimum of sal, average of sal. So these functions will provide you 3 different values. So those 3 different values we need to load into 3 different columns. Number of employees means count star. If I do count star, number of employees will come. And maximum salary, minimum salary, average salary. So now if I do these functions, Apart from the max, I need to use also count star. So if I use these methods, these functions, I get all this data from the salary column to these four columns: number of employees, maximum sal, minimum sal, and average sal. And rest of the thing is department ID. So here we need to count number of employees department wise, then move them to target. So we need to count number of employees in each department wise. Okay, then we need to move this column to the target column. So how we will get this value in the target table means department ID, in this particular department how many number of employees are working, and then what is the maximum salary of in that particular department, minimum salary of the particular department, and then average salary of the particular department. So that is how we need to get the data in the target tables. So here we need to apply two things. One is on salary column, the other one is a department ID column. So this is a mapping file. Next, sixth one. So in the sixth one, I have only one table, and I have another target table, that is EMP underscore manager underscore target. In the target table, I have only three columns: employee ID, first name, and the manager name. This is also a joiner transformation. So basically, we need to apply the self join here. Okay. So even though if we have one table, we can apply the join. So that becomes a self join. So here the source table having multiple records. In the target table we have only three columns, and source table we have multiple columns. And what is the condition we need to apply here? These columns we don't need to load the data into the target table. So because these are the first two direct move. Sorry, first two are the direct move. So employee ID we can move it, first name we can directly move it, but rest of the column we should not move to the target. And then manager ID should be moved. But in how we need to move the manager ID, we need to apply the joiner transformation. Load only employee ID comma first name details with their manager names. So this is the condition. Load only employee ID. So we need to load employee ID in the manager name. Sorry, in the employee ID column. First name will come again, first name details with their manager name. So basically this column is used for applying the condition in the self join, because here the condition will be like this. Suppose if I want to write a self join, we need to create we have only one table, but we need to take the two instances, and the manager is also a kind of employee, right? Manager is also an employee in the organization. So here employee ID and the manager ID is not different. Manager ID is also one of the employee ID. So we need to pull the data from the same table. So we need to take the two instances of the single table. That is basically self join. Okay. So we will see how we need to write this while writing the queries for these mappings. Okay. Now this is the sixth mapping, and this is joiner transformation. And finally we have a rank transformation. This is another mapping. So here also we have a one table, that is employee table, and here first two columns we need to move directly to the target table columns, employee ID and the first name, and rest of the columns we should not move. And if you observe the target table, we have different columns: employee ID, first name, and salary. These columns are direct columns, but these columns are not there in the source table. So rank, dense tag, and the row number. So in the last class we have discussed these three things, right? Rank, dense rank, and the row number. How we will get these three? If we apply the rank function on the salary. So here how we need to get this? Based upon the salary column, right? So commission underscore PCT will not come into the target. Okay, this we don't need to move. But all these functions we need to apply only on the salary part. Here something is wrong. Let me modify this. Here we are applying these methods, right? All these three we need to apply on the only single salary column. So here we need to apply all. Here we need to apply. We should not move salary. We can move it salary directly, but if you want to get these things, we need to apply these methods on the salary itself. But the commission, manager ID, department ID, we don't move them. Okay, let me put here and here. just a moment. So this is a direct move and this is don't move. Okay, not this here. Commission, we don't require manager ID and we don't require department ID, and we required only the salary, and these three things we don't require. Let me remove this one, but there are these columns we have. Just a minute. Right, high date, salary. So this is the salary column. So from here I need this. Right, so now salary column, salary direct move. After this we don't move this commission hyphen PCT, we don't require. Manager ID is also not required. Department ID is also not required. Okay, so this is how we need to do. So these three records we don't move because we don't have the associate columns here. But how we need to get these three values? These values we need to get from the salary column only. But we need to apply the functions, right? What are the functions? Sorry, I have removed this. Just a moment, guys. So these are the functions which we need to, already copied here, right? So got it. Okay, just a moment. Right, so here we need to apply these three functions to get these values: rank, dense rank, and the row number. If you want to get these values, we need to apply these functions on the same salary column. Okay, so this is a rank transformation. This is another kind of mapping. So who will provide this mapping document? The business analyst provide this mapping document. Okay, but this is more technical. Even the business analyst don't provide these functions and everything. Okay, so the developer will identify appropriate functions. What functions or methods we need to apply? SQL functions which we need to apply on the specific columns. That the developer, because I make this is very easiest for you, because if I write high level, you don't know how we need to write the SQL queries and all. But in the real time, at the business point of view, they don't mention any method names like this. Round methods is date, high date, sum. So they don't mention this one. Okay, they simply write like I need sum of salary on department wise. That's it. You need to find out what method will get the sum of salary. Okay, that you need to work on. So here just I make it simple little bit, because you need to understand what kind of methods we need to utilize for loading the data from the source to target, and the developer will identify these methods basically. Okay, right, so this is a basically mapping sheet. So once we are clear with this mapping sheet, we need to go for the next step. So is it clear so far, both of you? So how the mapping should be seems like, we have a tables, data column names, data types, and then what kind of transformation rules we need to apply, and what's the target table and their columns. So if you're very much clear about this, then we can create some test data and then we can go for the test cases. Okay, this is the first and most important step which we need to understand the mapping document. Okay, now let us move on to the data validation. So now before writing the test cases, we need to get ready with the test data. So now assume that the data is moved to the target tables. Now the data is available in the target table. Now we need to verify the data is accurately loaded in the target table based upon the transformation rules, according to the transformation rules or not. That we need to verify, right? How we need to verify? This is the challenging thing, and the ETL tester job will start from here. Okay, as soon as we get this document, we need to prepare our own queries to validate the data in the target tables. So how we need to create? I'll tell you how we need to create. For example, let me open the database, source database. Okay, so source database, let me check this. So currently I have only one database I will use as a source and target. Okay, but actually in the real time you will have multiple databases. Source are different, so target are different. Okay, so here I have a HRDW database. This is again Oracle database. I am connecting to this database. I have multiple tables. I have source tables and also I have a target tables are here. Okay, so now what I want to do is just think about high level. If you have this mapping, okay, what I'm saying here, hire date, we need to get the experience based on the hire date. That's the one thing. And I need to add salary and commission, and plus I'm adding these two columns and I'll get the total salary that I want to move to the target table. Now what is the target table contains? Employee ID, first name, last name, email, phone number, experience, job ID, total salary, manager ID, and department ID. So these are the columns we have in the target table. Only this data will be available. Now what we need to check here is, as a ETL testing point of view, we need to check source as well as target, right? So how we need to compare those two things? First of all, we should have the data from the source and also target, then the comparison come into the picture, right? So first let us connect to the source, then check the data from the source table. Check the data from the source table. Okay, now let me write a query in the source. This is my query. So let me execute this query. See this. First of all, let us understand this query, then we move on. What is the transformation I'm saying here? All employee ID, first name, last name, email, and phone number. Till these columns, everything is a direct move, right? So in the query, I mentioned select employee ID, first name, last name, email, phone number. Till this, everything is the same. Now, before moving this record to the target table, we need to apply this particular function on the hire date column, right? Then we will get the experience. So how we need to write this query? So this is the same function I have applied in the hire date. So this is a column alias. This experience is a column alias of this particular expression. Now job ID is as usual, we need to get direct move. And now when you come to the salary, we need to add salary and commission, then becomes the total salary. So how we need to add these two, salary and commission? We have a method called, sometimes what happens is in salary or commission there will be some null values. Okay, so we cannot perform arithmetic operations on null values. So what we need to do is we need to convert the null value into 0, then we can add those values. Okay, so for that in Oracle we have a method called as, we have a function called as NVL. NVL is a function, null value. So what this function will do is, if there is any null value present in the column, that null value will be replaced with a 0. Okay, that is our requirement here. If you see here, salary plus commission, but check null values in each column, and if null values encountered, then overwrite it with the 0. That's my requirement. So now what I need to do here, before adding this commission and salary, I need to convert this salary column. If there is any null value, convert that into 0. Now this will give you the salary and this will give you the commission. Now adding those two, and I'm adding the column alias, total underscore salary. Now we applied this transformation, and remaining the manager ID, department ID is a direct move. So directly mention manager ID, department ID from employees. Is the source table or target table? This is a source table. We are pulling the data from the source table after applying the transformation. We are not directly pulling the data from the source table. After applying the transformation, the data will be like this. Okay, this data we are pulling after applying the transformation, so that the same data should be populated in the target database. That is our expectation, right? So this is a data which the data we are getting here. If you observe these columns, employee ID, first name, last name, email, phone number, experience. See this, we got the experience in the years. That is how we are expecting in the target table. And the total salary also we are getting here. This is a total salary, right? So this is how we are expecting in the target table. Now what happens is, After applying this transformation, if I write query, this query will populate this data like this. Now, the data even in the target table should have the same kind of data, right? Now we need to validate. So this is the data we are pulling from the source. Okay. Now we need to pull the data from the target. We need to pull the data from the target. How to write the query now? What is the target table currently we have? EMP underscore total salary underscore target. This is my target table, right? So now how we need to write the query for the target table? We need to write the query simple like this. This is a query. So select employee ID, first name, last name, email, phone number. There is experience column directly in the target table, right? There is an experience column is there in the target table. If you observe here, there is an experience column is there and total underscore salary column is also there in the target table. So here we don't apply any transformation because this table contains the data. After applying the transformation, the developer moved the data into the target table. So right now, so whatever data we are getting from the source table after applying this transformation, the same data should be available in this target table. That is our expectation. Right now execute this particular query. Now it will also give you the data, but currently we don't know whether this data is accurate or not. We don't know. But developer is moved the data from the source to target. But currently we have a source data and currently we have a target data. Now we need to verify both the data is exactly same or not. How we need to verify? Here we need to apply two things. One is we need to use minus operator and then we need to use join condition. By using these two, we can check the data is accurate in the both the tables or not. Okay, so how we can do this? Simply, suppose if I take table A, comma B, I already explained this in the SQL classes. This is more important. Okay, if I take A comma B, observe this very simple. Okay, in the A table, let me take this another way. I have two tables. If you understand this, all mappings you can easily write it. Okay. Now if I have a table A which contains a few records, let us say 1 or 2, 3, 4, 5 records I have. On the table B, I have few more records like 1, 2, 3 or 1, 2, sorry, 3 is there, right? So here 2 is there and 4, 6, 7, 8 and here let us say 6 or 7. Okay, this is the data I have in the A and B. Now what we need to do is I want to check this data and this one, second and first one is exactly equal or not. How we need to verify? First we need to apply A minus B. What A minus B will return? A minus B will return the records present in A which are not present in B. The records present in A which are not present in B. So what are those records? 1, 2, 3. 1, 2 is present in B. Sorry, 1, 2 is present in B. 3 is not there, so it will return 3. 2 is already there. 3 is not there again. Again 3 is already mentioned. And 6 and 7. 6 and 7 is already there. So only it will return only 3. Suppose if I say B minus A, see B minus A which will return the records present in B which are not present in A. What are those records? 1 is present in A, 2 is present in B, A, 4 is also present or no? 4 is not present, so 4. 6 is present, 7 is present and 8 is not present in A, so it will return 8. Now B minus A will give you the records which are there in B, those are not there in the A. Now if I join these two data like A minus B, join B minus A, what this will return? It will give you 3, 4 and 8, right? So this is a one scenario. if the data is different, the data is exactly not equal, right? This one A and B data is different, so that we are getting the output. Now if I see the one more scenario, let us take now data is exactly the same, then what it will return? I have a table X, let us say X, let us say Y. I have two tables now, and in the X I have 1 2 3, and in the Y also I have 1, okay, same data, I have 2 and I have a 3. Now how we need to check whether data is exactly same or not in X and Y? First we need to check X minus Y. What X minus Y will give you? The records which are present in X which are not there in the Y. So what are those records? There are no records, so 0 it will return. Now similarly Y minus X, what this will return? Records which are present in Y, they are not present in X. So is there any records like that? No records. So this is also will return 0. Now if I say X minus Y join Y minus X minus Y join Y minus X, what this will return? 0. Join 0. Finally 0 will return. So if I return this query as a 0, that means the data is exactly same in the two tables. Is it clear, both of you? If you understand this very clearly, rest of the things will make very easy. Okay. So how we need to check the data is exactly same in the tables? The first thing is we need to join two tables. We need to apply the minus between the two tables, right table and the left table. And then we need to check the B minus A, left table minus right table. Then we need to apply the join between, so join means union. Okay. We need union operator. So union B minus A. Okay. Now this query, final query, this is a final query. If the final query returns 0, that means the data is exactly same in the X and Y. Okay. Now this is how we need to write a query for check the data validation. Now coming to our scenario. Now in the first query, will return the data from the source. The same data should be available in the target. That is our expectation, right? But how we will know both the data is same or not? We need to use minus operator between these two. Minus this one. Remove this column now. Okay, the first query minus the second query. Okay, let us check this is returning 0 or not first of all. Execute this query. I'll split in the multiple lines. Okay, this is a query from the source table and this is a query from the target table. Okay, if I do minus, what it will return? That records which are there in this query and which are not there in this particular query. Okay, that will be written. So it should return 0. That is our expectation because the data should be accurate. Execute. Now it returns nothing. That means almost whatever records we have in this particular query returns, the same records are available under this particular table. That is confirmed now. Now what we need to do is we need to reverse this query. B minus A. What we need to do now? This is the target query. Okay, minus source query. Minus source query. Now if I run this should also return 0 because there should not be any records which are there in the right table and which are not there in the second table. So now let us execute this. It should also return nothing, 0. That means the records which are written by this table are exactly same of the records which are returning by this particular query. Now we need to join both the things. So here we need to apply union operator. Union. So we should not close this query. Okay. And here also we should not close. So finally this is the end, right? So here you can close. So this is a huge query. Now if I execute this entire query, then it will check if it is written nothing. That means the data is exactly same between the source table as well as target table after applying the transformations. Okay. Now execute this. Now there are no records. So that's completely empty. That means data is exactly same on the source table and the target table after applying the transformation. Is it clear, everyone? Both of you is clear so far? Okay, so this is how we need to prepare our test data to validate these mappings. Same, if you understand this, it is common for every mapping. Okay, I'll show you one more mapping. So here we prepared this data, right? This is the data, test data. If we want to validate the target database, we need to execute this. Okay, and put the data in the validation query. So prepare one more sheet here. This is our test data. Okay, data validation query. So I have mapping one. I have created this much query. If I execute this query, if I return 0, that means the data is accurate. Now the second mapping, mapping 2. So in the mapping 2, this is my source table HR.employees and this is my target table. Now in the source table, I don't want to move all these records. Okay, now what I want to do is I want to get only salary and salary column also I don't want to get, but sum of salary and department wise I require. That is my expectation. And first I need to calculate the sum of salary department wise and then I need to load the data into the target table, sum of salary and department ID. So in the target table I have only two columns. Okay, so in these two columns I need to get the data sum of salary here from the salary column and then here I want to get the department ID. So this is a direct move. Okay, now let us check this is correct or not. As I said, first thing, this is a mapping 1. You can, so you can mapping 1 here I'll write query for mapping 1. This is a huge query. Okay, now I'll write query for mapping 2. Query for mapping 2. Right, query for mapping 2. Let us understand the mapping first. So in the mapping, I have these columns employees table, but I want to move only the salary, not only salary. I need to calculate sum of salaries of department wise. Then I need to load the data into these columns. Okay. So how we need to write the query? So let us see the data validation query here. This is the query first of all. See this. First we need to check the source, right? Then target. So if you want to get this data from the source, this is how we need to get the data. See now, from the source, I need to get only salary column, but not exactly salary. I want to apply this sum of salary and I need to get the department. Only these two columns are required from the source table. And salary column also directly not required, but this is required for calculating the sum of salaries and department wise. So how we need to write this particular query? Select department ID, comma, sum of salary, and I'm putting some alias here for sum of salary from employees group by department ID. This is a query. So when I execute this query, whichever output we are getting, this is the exact output which we need to give to the target table. Sum of salary, department ID, right? Sum of salary and department ID. So this is exactly the column. This is exactly the query, whichever written in the data. So that data we need to load into the target table. This is our expectation. And this data we are pulling from the source now. After applying the transformation, this is the actual data which we need to load into the target table. Now let us check the data in the target table. This is the source. First query is for the source. So what is the target table? This is my target table. Sum underscore sal underscore depwise underscore trg. Now directly pull this record. Select what are the column? Sum underscore salary. Sum underscore salary. You can write small letters, capital letters because database is not case sensitive. Okay. Select sum underscore sal underscore sum underscore salary column. Sum underscore salary, and the other column is department underscore ID. Department underscore ID from which table? It is sum underscore sal underscore department ID salary table. So this is a table. This is a target table. Now if I execute this query against the source table, whatever data we are getting, and this query also should return the same data. right? That is our expectation. Then the target table data is accurate. Now first let us execute the source. So it contains few records. There are 12 records are returned, and the department ID, sum of salary we get. Each and every department, suppose 30 is the department. In the 30th department there are many member of employees are working, and this is sum of salaries of those employees. Okay, and the second query is sum of salary comma department ID. Okay, from sum of salary department wise target. This is a target table. Now execute this. Is giving wrong sum underscore salary, something wrong with the column name. Just a moment. Sum underscore salary, right? Sum underscore salary comma department ID. Yeah, we need to we don't need to apply any group function here. Sum of salary department ID from sum of invalid identifier. Let us check the table column is correct or not. How to check the structure of the table? Describe sum underscore dipwise underscore trg. So if I execute this command, it will give you the columns list. It contains error. Error object does not exist. So this table does not exist. I think this because of this table having different name. Let me check this table is there or not first of all. Sum underscore sal underscore depwise underscore target. Yeah, it is there because the name is something else. Sum underscore sal underscore sum underscore one minute. Sum underscore sal underscore depwise underscore trg. This is the exactly table. Let me check this. It should contains two columns. Yeah, department ID, total sum. Sorry, the table name is wrong. This is also correct. I copied wrongly. Okay, so now we executed the query against the target database. So execute this particular query. Let me remove this. This is the table name, right? This is my table name. Right, now execute this query against the target table. This you should also give the same. No, it's not giving sum of salary. Let us see what are the column. Okay, it is a total salary, I guess. Total underscore salary. Total underscore salary. Right? So this is a data it is giving. Not sum of salary, this is total. Okay, now we need to check the data is correct or not. So this is the data we are pulling from the source table, and this should be same as the data which are pulling from the target table. How we need to check again? Same method, minus, and this will give you the data which is there in the data which is written from this first query, and the same data which is not there in the second query, that will be written if there is any records. Or same thing again, we need to reverse this. First target minus source query, and we need to execute this again, and both should return 0. This should return 0. Oh, still it is giving some records. Just a moment. Select department ID, sum of salary, sum salary from employees group by department ID. Okay, so this is the execute this query. 12 records we have, and if I execute this, this is also having 12 records. Now we need to put the columns in the same order. Okay, so first department ID should come, right? So then total salary. Here there is a sum of salary, but here we can have total salary, no issues. Let us change total underscore salary, right? And employee. So first column is department ID, and the second column is total salary. So let us execute the first one. Get 12 records, employee ID and total salary, and this will give you the second one. Again some missing expression. Select department underscore ID, total salary from something wrong. Salary department. Yes. Oh, sorry. So syntactical error. So execute this. Okay, 12. Now if I execute this, if the data is present in the first and second, so still there is some mismatch in the data. Okay, because even though if I see minus, the records which are there in the source, which are not there in the second. So that is giving here. Let us check once again. It should not be there. If it is there, that is a mistake. Okay, that is a bug. Okay, I make so a few tables as a something wrong because we need to find some defects, right? So that's the reason I make it something wrong data, and don't worry about it. So let me execute again first one. This will give you 100, 30, null, 90, 20, and this will also give. There is some difference. Okay, 100, 30, next null. So there is some difference. Okay. So what we can do here is now this is a minus query, right? Here itself it is giving some data, means the data is not accurate. And again we no need to do this, but still we need to do this as a formality, right? So what we need to do is we can execute this query again. Total salary, right? So execute this. It is giving some data, right? Now we need to do the uh, union. This query union and this particular query. Here quotation should be required. And execute this. So, but there are still records are coming here. But what is our expectation? If the data is accurate, the data should not be present here. So this is completely wrong. This is not met our expectation. So we can make this as a bug. Okay, this mapping 2 has been failed. You need to check the target transformations. Sum of salary department wise. Yes. If you observe here, we already calculated sum of salary, right? So this will give you the sum of salary department wise. Okay, these are the total salary department wise. Okay, this is fine. But here in the target table, the same data, whichever the first record is getting, the same data we need to insert into this particular table. So it should also contain the same department ID, total salary. So when I execute this, the total salary 15600,24,900 is there. Let me check the first one. So something different, something wrong with the data itself. So that's the reason it is not giving. See, here we have a something. Here we have applied the sum of salary, right? So it will give the sum of salary, requirement department ID, and we can check it exactly by copying data. But that is a hard way of verifying the data. That is a not formal way. Okay, but this will give the accurate data. If the data is almost equal, exactly same, then it will not return any data. It will give the 0. But there are some records, there will be some mismatch happening here. So that's the reason it is not giving, because I intentionally make it actually. So what the reason behind this is, there should be some mismatch happen, right? So if I want to find some defect, there should be some mismatch happen after transformation. So here's transformations happened on the salary column. So in the target table, the data will be something different. So then only this will fail. Okay, so this is how we need to validate. This is a common. First of all, we need to do source query and target query minus source query minus target query, and then target query minus source query, then make union of them. So this will give you accurate data. If the data is equal, it returns nothing. If data is not equal, exactly not same, then it will return the data. Okay. Got it, Sandeep? So if you have only 5 or 10 records, you can just copy in the notepads or some Excel sheet. You can check the data. But in the real time, you have thousands and millions of data, right? So it is very difficult to copy in one place and check comparison and all. It's very toughest task. Okay, so this is another transformation we have mapping to. And similarly, we can also write the mappings. Similarly, we need to also write queries for each and every mapping. So if you come to the data validation sheet, so here I have created the queries for each and every mapping. So this is the first one I have told you just now. This is the second one, and this is the third one. So let me execute this mapping one. did I mistake something or not? Delete it. If the data is different, definitely it will fail. Query is correct, but data will be different, it will definitely fail. Oh, it is written is correct. Department ID salary. There is no. One second. Let me check the query which I have written. Is this correct or not? So this query is giving correct result. This is a mapping to. Sorry, just let us debug it. Mapping to. Let me check the query which I have written are correct or not. Select department ID, sum of salary or sum of salary as total salary from employees group by department ID minus department ID total salary from sum of sal department wise target. So this is perfect. So if I execute this, it should give 0. This is perfect. Yeah, 0. And second thing. So second total salary and department ID total salary just I have interchanged from sum salary department was target and department ID sum of salary from employees group by department ID. So everything is perfect. So this will also will give you 0. Perfect. Now if I run this entire query, it will give 0. Yes. But here we are not using any order by class, right? If I use order by class, you should use order by both the queries. But here we are not using any order by class. There may be some order of providing the columns. Let me check exactly what I did wrong here. So first department ID, sum of salary, just alias is different, nothing else. Maybe that is the reason I think. Let me check. Instead of total salary, let me put sum of salary itself. And from employees group by department ID. Perfect. Minus select department ID, total underscore salary. Okay. From sum of sal by target. This is perfect. Same query I have given here. Okay, let me check this. 1 second. Yeah, now it's working fine for me. So let me check the second query. Second query is select total salary. Okay, I have given this interchanged actually. Maybe that's the reason. I put this in the beginning. Yeah, this is a mistake I did actually. So in the above query, department ID is the first column. This is the second column. Department ID and the total salary from some salary department wise. Okay, good. So let me execute this. Perfect. Now just I did a mistake here because the order of columns exactly same. Okay, the above department ID sum of salary came next. But what I did is first I put the total salary, then department ID. Some order is changed. That's the reason it is failed. Now it is perfect. So it is returning nulls because the data is exactly same. So let me copy here. This is the query for mapping 2. Okay. So now let us go for another mapping. So you can write for others. Let me check here. I'll leave it to you for rest of the mappings. You can create your own queries as an assignment. So, but I'll give you this Excel sheet anyway. So, it's a mapping 2. Let us say mapping 3. Okay, how we have written this query. In the mapping 3, uh, all are direct move, right? So, all are direct move. Only thing is, I need to load the records at department wise. Only records, this is basically filter transformation, right? All the records which have department ID 10 will be loaded to the target. Rest of other records will be dropped. So that is our uh, transformation. That is a filter transformation. So how we need to write the source query now? I need to get all the records, but employee ID should be 10. Only those records I need to get. So how we need to write here? We can also use star. Okay, select star from which column. So star we cannot use because on department ID column we need to apply, right? So that's the reason. So first we don't touch all the columns, just we need to touch only department ID column, and this is our direct move. So what we can do is, so select, let me put all the columns, then let me copy this. You can also put, okay, 1 minute. You no need to apply any transformation on the column. You remember here, can you see the difference? A mapping sheet, we no need to apply any transformation, any condition on the column. This is not expression transformation, right? So we need to get all the data. Only thing is we need to filter the records. At the end of query, we need to filter the records. So department ID should be there. We no need to apply anything on the department ID column. So we can still use star. Star means it will get all the records. But thing is, we need to filter the records by using department ID is equal to 10. So when I execute this will give you the records, right? This is only, we have only one record, and the same record should be available in the target table. So now let us see the target table data. So here only the filter transformation. Target table is this one, EMP, DEPET and TRG. So let us say select star from this table and now execute. We have only one data. So how we need to compare again? Same, minus. And especially for filter transformation, make sure the number of records should be same. Okay, sorry, number of records should not be same, because this is a filter. After applying the filter, may or may not same number of records. So here 10 minus this one, now 0. Perfect. Now we need to use union. I need to reverse this query. So this one is a target query minus and the first query, source query. So now when I execute this, this will also give the 0. So the final query should be 0. Then only the data will be accurate. Okay. So this is the query. We need to use it for the mapping 3. Query for mapping 3. Okay. So you should practice all these things. So rest of the mappings I left to you. So just practice them, because I'll also provide this Excel sheet to you. You can practice rest of the mappings. Just if we have only 3 to 4, right? 4, 5, 6, 7. But here you need to write different kinds of queries. Just if you're familiar with the joins and subqueries, you can easily do it. Most of them are joins. Okay. So in the data validation sheet, I have provided all the queries. This is mapping 2. This is mapping 4, 5, and 6. So in all the queries, the common thing is we need to use minus, and also we need to use a union. So these are the common things for checking the accuracy of the data, both the tables. Okay, so this is becomes the queries. Queries means these are test queries, test data. Now as soon as we get this mapping sheet or mapping document, we need to create our queries to validate the target table for every mapping. Okay, so this is our tester job. Development team, they won't provide any queries. Okay, they will create their own SQL queries for pull the data and then insert the data in the same. They also do the same thing actually. Suppose if you see what developer will do is, I want to apply the filter transformation, they will create this particular query. Whatever the data we are getting from this query, that data will be directly inserted into the target table. Simple. Okay, so that way they will do it. I will show you what are all the scripts that developer will write, but our scripts are a little bit huge because we need to verify the data in the source as well as the target. But developer write only one query. That query will pull the data from the source, load the data into the target. That's the only query he will write. But ours, we need to write the source query as well as target query, and we need to join them. Okay, our job is little more complex. So this is how we need to write our test data for all the mappings. This is a job of ETL tester. Now once we data is ready and everything done, we have to start with writing our test cases. Okay, let me share you the test cases document. And everyone is clear so far how the mapping sheet will be, how we need to understand the mappings, how we need to create the test data for checking those mappings. Okay, so now let us move on to the test cases. So for writing the test cases, this data is very much required. Okay, we need to think about different areas, not only mappings. We need to also focus on schema validations and number count, number of records count. Okay, so let me share the test case document. Now this is our test cases document. Now I have created two different sheets for two different scenarios. One is source schema validation. As a ETL tester, we need to also validate the source schemas and target schema validation and then mapping test cases. Okay, so now let me go through one by one and then I'll send this Excel sheet. You can review this later. And first thing is we need to focus on source schema validation. So if you want to validate the source schema, first of all, we need to know the data model. So what are all tables are available, what are the data types we have, and what are the size of those data types that we need to have. So now what are the test cases we can usually write for source data validation, source schema validation. Schema is nothing but a collection of tables. Okay. Now the test case one. So the ID will be like this. Is a format. The format ID will be like this usually. TC underscore HRSRC. SRC means source underscore EMP01, 02, 03, 04, and 05. And here I have written the source schema validation test cases only for employee table. And rest of the tables you have to create your own. Okay, I'll leave to you. Okay, you guys you need to practice. Okay, for only employees table, I have created the validations. So what are the different scenarios we need to validate? So the first scenario will be, or first test case will be like this. Check the number of columns in employees table. How to check the number of columns? How to get the number of columns in a table? Very simple. There is a table in Oracle, user underscore tab underscore column. So this table, this is a system defined table. There are two kinds of tables available in the database. One is user defined tables and system tables. Usually system tables contains the data about all the tables, all the views and indexes and so on. But user tables are created by our users. So if you want to check the schema validation, if you want to check the how many number of columns present in this particular table, how we need to verify. So this is a specific query which we need to execute. Select count star from user tab columns. Let me execute this query first. What this will return. So this is a query, right? Now when I execute this, this will give you 100. So what is 100? In this particular table, there are 100 records are there. Let me remove the count star. Just give the star. Now what this will give you? This will give you all the 100 records. So what the columns it contains? Table names, column names, data type, and so on. So because this is all system related information. As soon as you created the new table, that table information will be logged into this particular system table. So user tab underscore columns is a system table. We won't create these tables. Okay? By default, the database will contain these tables. And these tables are very specific to Oracle. If you go for some other databases, the table names will be different. And there is some different tables are available. But there must be a table which contains all the system related information. Every database is having the system tables and user tables. Now here select star from user underscore tab underscore columns. This table contains all the tables and their columns and their data types and lot more information. So in this particular table, what we required as per our test case, we need to check number of columns in a employee table. Number of columns in a employee table. Now when you put this condition here, it will give you the information about all the tables, right? Now what I will do is where I'll say table underscore name equal to single quotations, I'll provide the table name employees. Now what happens is this will give you the information about the employees table. So employees table having these many columns. Okay. Now what I want to do is I want to just count number of columns. I don't want all the columns. Just I want to count how many columns are there. Just put the count here method. This is a function. So this will give you how many number of columns present in the employee table. So this is the same test query. So the same query you need to write here. select count star from user underscore tab underscore column where table underscore name equal to employees. Now what is our expected? 11 is expected. So while execution time, if you are getting the same number of records, just put the query here value and comments and make it as a parse. Okay. So this is a basically check the number of columns present in a table. Next, check the data type of the columns in a table. Check the data type of the columns in a table. So every column, what is the data type we have? That we need to verify. So for that, I have created this particular query. Select, again same table. Okay. So select column name and their data type. These two columns are available in the system table, right? Column name and the data type, and which table? Where table underscore name is equal to employees. So when I execute this particular query, it will give you column name and the data type. So this we need to validate against the data model. So where is our data model present? In the mapping sheet, right? So in the mapping sheet, we have in the source table, we have this structure, right? With the same structure, column names, data type should be matched with this particular data. Okay. So that is another query we have to write. That is another test case. One second, right? So here, check the data type of the columns in employee table. This is the query, and verify result should be as per our design. Next, so check the size of the columns in employees table. Size of the column is different, and here this is only data type, right? And the size of the column means select a column name data underscore length. There is a field called data underscore length from user tab columns. Okay, this is the system table where table name is equal to employee. For this particular table, I am capturing the column name and the data length. So that is what we need to verify. So execute this one. Will give you data type and data column and their data length. How much length we have defined? This employee ID is maximum 22 letters. First name is 20 letters. Last name is 25 letters. So this is the data we have. So this we need to verify against the data source. So first thing is check number of columns available and the data type of those columns and data size of those columns. And the third thing, fourth one is constraints of the columns. So for each column, what are all constraints have been created? So that information also we will get from the same table. So when I execute this particular query, you will get the same constraints. Let me copy this. Right, so not copied. Okay, so column name and the constraint name from the same table. User underscore cons underscore columns. User underscore cons underscore columns. So this is a different table again. See now, the above three we have used user underscore tab underscore columns, but this time this table is different. User underscore tab underscore columns. You need to remember these tables, very important. And the above is the user underscore this one, user underscore cons underscore columns. Okay, this is another table. So from this table we will get the constraint name, column name and appropriate constraint name from this particular table where table name is equal to employees. Now when I execute this query, it will give you the constraints and their column names. See now, these are the column names and appropriate constraints names have been provided. Okay, manager function of FK means foreign key and salary minimum means this is a check constraint, right? PK means primary key, NN means not null. Okay, so you can verify the columns as well as their constraints. So this is another test case. And the last one is check indexes of the columns in employee table. So indexes have been basically created for the columns for improving the performance. So here what are all indexes have been created for those columns that we can verify. So here I can check this is a query. So here select column underscore name index underscore name from DBA underscore IND underscore columns. The table is different here again. DBA underscore IND underscore columns. You need to remember these names. Okay, these are all system tables. From the system tables we will get the data. So here it will provide the column name and the index name which is created on the column from this particular table. And here we need to also provide the owner of the tables. So here my table owner is HR1. Okay, let's do this. Now it will give you the column name and the index name. See, IX means index. Okay, so this index name is created on this. This index is created on this. Almost every column is having the index created, and this we need to verify with the data model. Right, so for every table, every source table, we need to validate these 5 things. And queries are exactly the same. Only thing is you need to change the table names. That's it. So in the source tables, I have 5 to 6 tables, right, in the source schema. So for all rest of the tables, you need to write these queries. So I have created these 5 test cases only for employees table. Similarly, you should create uh, test cases for the rest of the tables which are there in the source schemas. Got it? Can you? So now, so same test cases will repeat again and again for every table. Here these 5 are employees table. Let us take department table and write the same queries. The only thing is here you need to change the table name. Okay, so this is a employee schema validation test cases. Then target schema validation test cases. Here also you need to use the same, exactly same, not much difference. Here number of columns we need to verify for the target table, data type of the columns, size of the columns, constraints on the columns, and indexes created on the columns. So for these columns, again the same queries, only thing is to change the table names. Okay, nothing is different, but only this is the target tables. Similarly, you have to write for the other tables, other target tables. Okay. Now, finally, move on to the mapping test cases. These are very important. So, in the mapping test cases, we need to write like this. Let me show you. Right. So, mapping test case, for every mapping, we can write number of test cases. For example, let us see here. TC underscore map1 underscore 01, map1 underscore 02, map1 underscore 03, map of 4, 5, 6, 7, 8. So I have created one test case. This is all one test case only. Okay, but these are all test cases belongs to first mapping. Okay, one mapping contains n number of test cases. One mapping can contain n number of test cases. Remember this point, very important. One mapping contains n number of test cases. Okay, so here for mapping 1 I have created around 7 test cases. You can also similarly create n number of test cases for other mappings. So let us see what are all test cases have been created for first mapping. So what is the first test case? Check number of records present in a source table. This is the first test case. In the source table, number count. We need to also count number of records in the source and target, right? So here the count check. So check number of records present in a source table. Data validation type. This is the data validation category. How we need to count? Select count star from employees. This is a query. So what is an expected 107 record should be there in the source table. And pass or failure message we can update later. Now come to the second test case. Check number of records present in a target table after data is loaded. That is the second test case for the same mapping. So this is a number of records in a target table after data is loaded. This is also part of the data validation. Step number 2. Now the same query, select count star from employee total salary underscore target. This is a target table. Now expected records are 107. Now third test case for the same mapping. Check the records pulled from source tables after transformation applied. Check the records pulled from the source table after transformation applied. So the first query which I have given, right? So that test case. First query. See now. We have written the first query against the source table, second query against the target table, then we have do the minus, then union, right? So this is query which I have created further getting the data from the source table. Okay, so that's the reason. Check the records pulled from the source table after transformations applied. So this is a query which will pull the record from the source table after applying the transformation. See, we have applied the transformation rule here, and then the record should be as per our expectation. Okay, and then the third test case, check the records loaded into the target tables. Here the third test case is what are the records pulled from the source table, and the fourth test case is what are all the records loaded into the target tables. How we need to check? We need to execute this query against the target table. So emp underscore total sal underscore trg. So this is the target table. Okay, now we need to pull all the columns from the target table, then it will give you the data. Now this data also we need to validate. And the next test case, fifth one, means check the records present in a source table which are not in the target table. What does it mean? We need to apply the minus query here. Check the records present in a source table which are not in the target table. So we need to apply the first query minus the second query. The first query against the source table, the second query is against the target table, and the minus. It will give you the records present in a source table which are not present in a target table. It should be no records. That is our expectation here, right? It should be 0 records. Next, sixth one. Check the records present in a target table which are not in the source table. Check the records which are present in a target table but not in the source table. So this is the query again. The first query, this is second query which is targeting to the target table, and this query should be raised against the source table and minus. This is basically A minus B, this is basically B minus C. That's it. So check the records present in a target table which are not there in the source table. That we need to verify, and this should not return any records. No records found should be our expectation. Next, seventh one, check if any records missed from source to target tables. How we need to verify? Then we need to actually apply the union operator. So this query, so A minus B means source table minus target table, union target table query minus source table. This is exactly query which we have created for mapping 1. Checking the mapping 1. Okay, so now this will become the end-to-end test case. So other first 3 to 4 test cases are part of this one, but the last one should be the 7th one. This is exactly the end-to-end test case. Now the last test case, check if any duplicate records in the target tables. That is also very important. Sometimes duplicate records will be there. So how we need to check whether any duplicate records is in the target table or not? This is the query. This query, let me explain this query. This query is applicable for any kind of table. Okay, you can use the same query for any kind of table if you want to check any duplicate records present in table or not. So let me execute this one. So just me copy this. See, now select star from emp underscore total salary target where row id in. So keep this query one side. This is basically sub query. So in the subquery, first it will execute an internal query, right? So what internal query will return, that will become the input of the outer query. So here select row ID. Row ID is called as a judo column in the Oracle. Okay, and actually employee total sal target doesn't have this column, row ID, column name. So there are some judo columns in Oracle. So this will give you each and every row contains some row ID number. Okay. So when I execute only internal query, what this will return? Let us see. So select row ID from emp underscore total sal underscore target, group by row ID having count star greater than equal to 1. See now, if I don't provide any having count, what this will return? Let us see. First let us understand row ID. What is row ID will return? So execute this. It will give you this kind of information. This is basically some hexadecimal codes will return. So every row contains this particular ID. Every row is identified with this particular ID. Okay. If we want to verify is there any duplicate rows are present in a table, we can check these row IDs. Okay. So every row having a unique ID. So this query will give you all the row IDs. Now, in addition, I want to add group by row ID having, so group by row ID. If I say group by row ID, what happens? it will give you if there are any it will also give the same thing group by row id means here row id from emp total sal group by row id. If you have multiple row ids it will group together. Okay, and we need to apply one more condition with this, having count star means number of group ids greater than 1. So it will run this. If there is any row id is duplicated, then it will return some value. It will return that particular row id if it is duplicated. If it is not duplicated, then it returns null, and the same out will become the input of the outer query. So here we need to use the exact table. Select star means we are getting all the rows here, but internal query doesn't return any rows. It will just return the row id, not the exactly the values. So based upon the row id, we are getting the values here. Select star from employee total salary target where row id in. If suppose internal query is return some row id, and based upon that row id we are getting this particular data. Okay, so that's the reason. If it doesn't return any row id inside, even we don't get any data outside. What does it mean? Indirectly there are no duplicate records available in the table. So now when I execute this, I don't get any data. So that means there are no records available, duplicate records available. Okay, so this is a standard query. If you want to find duplicate records in a table, any table, this will applicable for all the tables if you want to verify the duplication. Okay, so now the final validation will be, is there any duplicate records present in a table or not? That we need to verify. So for that we need to write this particular query. So it should, as per our expectation, it should not have any duplicate records. Fine. So for one mapping we have to create these many test cases. For every mapping, how many test cases we will come? We will get 7, 8 number of test cases for one mapping. So how many mappings I have written? I have written 7 mappings. 7 into how many test cases? 8. 7 into 8. Those many number of test cases we can write. Right. So rest of the test cases I leave with you. So just please complete this as an assignment before coming to the next week. Meanwhile, if you find some time, just finish them. Okay. Because I'll provide all these documents. Can we do data injection? So that is again part of the security kind of stuff. So this is not part of the ETL. Okay. So if I do some kind of injection, it is not, the data will be different, right? So that we cannot do here. So this is only the thing is validation part in the target as a source and target, and the injection and that and all comes from the as part of the security testing. Okay, not from here. So here the complete focus is on the data only. Okay. Now these are all the test cases. Now this is the source schema test cases. You need to complete rest of the tables, and the target schema validation also you need to yes, we have a separate database for testers. Yes. Okay. And in the second sheet, target schema validation, you need to complete the rest of the test cases for other tables. And mapping test cases, I have created test cases only for first mapping, and rest of the mappings you need to do the same test cases. You need to do the same test cases repetition for other mappings. Okay, so if you find some time, this is a completely documentation work. So this and all happen during the design time, test case design, test case analysis, test case reviews, right? At that time we need to complete this. As soon as the developer confirmed the ETL jobs have been completed, at that time we need to execute these test cases. Okay, now I'll take 5 more minutes for you. So just a moment, I'll show you actually how the developer will implement the ETL scripts, and then how they will load in data into the target tables. Okay, just a moment. Let me show you the ETL scripts. I will share with you two things. One is ETL scripts, and I will also give you the ETL tables. Okay, so if you already have Oracle is connected, just create one user like HR1 user, and I'll provide you this SQL file. If you open this in the notepad, it will have all the tables and schemas and structures. Only thing is you need to select all the stuff and paste it in ETL developer and execute. Select all and execute. It will automatically create all the source tables as well as target tables. Okay, so ETL underscore tables. This is the one file I will provide you. This file contains all the source tables and also target tables. Everything automatically creates and the data is also automatically populated. This is the first thing you need to do. And now I'll show you ETL scripts. So let me open this. So usually in the developer, what they will do is if they want to clear the data in the target tables, they will just execute the delete commands if they want to delete data. Now these are exactly ETL scripts. So these are the same queries we have also created, right? So instead of select, they will write insert statement. So this query they have created against the source table, and whatever data they have pulled from the source table, the same data will be insert into the target table. See now, this is the statement we have also created. The same set of data will be inserted into the target table by using insert into command. So same for filter transformation, agriculture, joined aggregators, the same thing. So different kinds of ETL queries they have created and they will execute these queries always. As soon as they have executed these queries, the data will be populated in the target tables. Okay. And how to validate the script, how to validate the data is present in the target tables or not, just execute these queries. It will give you the records from the target tables. And if you want to clean up the target tables, just execute the beginning commands. So if you execute this first command, delete commands, this will clear the data in the target tables. And then run these queries again, ETL scripts, then the data will be populated in the ETL scripts, ETL tables or target tables. Okay, so this is the ETL scripts document I have created. Just you need to use this document and create, go through this document. Okay, I have already given these queries. So the thing is, when I executed this one, the first file, two files I will provide you today. First thing is what you need to do is you need to execute these scripts under ETL underscore tables. This will create all source tables as well as target tables. This will create all the source tables as well as target tables. But in the target tables, you don't have any records. The target tables, you don't have any records. But source tables, you will have some records. And then next step is you need to use this script for populating the data in the target tables. So suppose if there are any records in the target table, you can use these commands to delete those records and run only these ETL scripts. If I run these ETL scripts, the data will be populated in the target table. Actually, this job is done by the ETL developer, not tester. Okay. Once the data is loaded, then we have to execute our own test queries for validating the data in the target tables. Okay. Is it clear? Everyone? Fine. So I'll provide you these two files, ETL scripts and the ETL tables. The first of all, you need to create all the source and tables, source and target tables, and then populate the data by using ETL scripts. And then do some documentation work. So create the test cases for source schema validation and create the test cases for target schema validations for all the tables, and then create the test cases for mappings. What are all mappings I have covered so far? For every mapping, you need to create your create test cases for every mapping. So these are the mapping I have created. You can see this mapping sheet. Okay, I'll send you these two Excel files and script files, and just complete them from your side before coming to the next class in the next weekend. Okay, so I'll stop for today here. So any questions, anyone?